Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and I welcome Rex VK7MO to the studio. Hello, Rex.
Thank you, Justin. Yeah.
And just before we get underway, wish to acknowledge Tasmanian Aboriginal people with the traditional owners of the land upon which we're presenting tonight, and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. And I'll just point out hello to Lionel, Raymond, Andrew and Ken. And Ken, you're at Hockey Tika on the West Coast. Now, you sparked Rex's interest.
But I don't think he's permanently there.
Oh, no. He's permanently in Christchurch, I think.
That's right. Yeah.
But sparked a bit of interest from the point of view of a 2 metre contact to the west coast of
even higher. But since Bob ZL3TY has decided to get interested in pottery rather than amateur radio, we haven't had anybody on the west coast.
Right. Okay.
On VHF.
Okay. So Ken, you might need to take some 2 metre beams and some power amplifiers with you.
10 gigs as well.
And 10 gigs as well. Yeah, just throw that in as well. Okay, so now I've got Rex in the studio because we had an event.
We did.
So tell us about the event, Rex, and I'll set this all up so that it's all ready to go.
There was an event on the 24th of March, just a few days ago, and this is very close to the equinox, which was on the 20th of March.
Okay.
And if you can get the sun to explode and produce a CME very close to the equinox, it produces much stronger auroras, because around the equinox, cracks open in the Earth's magnetic field.
Right, okay.
And so this event, some people said, was the strongest event since 1917. Not 1917, 2017. It wasn't that strong while it was around Australia. I think that its peak was when it was somewhere else around the world.
Okay.
But it's certainly worth showing what happened.
Now, one of the things that I noticed for this event was, and I sent you the screen grab, was there was a reasonable amount of correlation between the NOAA, it's NOAA, isn't it?
Yes.
Yeah, the NOAA levels and the Australian levels.
Australia was still less.
Oh, correct, but there was less of a difference.
Yes.
So which I thought was interesting. So
yeah.
Okay.
Now, the if we go to the next slide, there's a couple of physicists, Russell and McFerron, have suggested that this is caused by an alignment of the Earth's and the Sun's magnetic fields. Now, I don't think it's. I think that's a gross simplification, but the reality is, you do get peaks at the equinox of auroral activity.
How strong is the solar magnetic field? It can't be that strong. It's a long way away.
Well, it's sufficiently strong that the ionised particles that go past the Earth go many Earth diameters past, and then the Earth's magnetic field takes over and brings them back, and that's when you get the aurora.
Right.
So I think probably about 3 Earth radius away, the Earth's magnetic field and the Sun's magnetic field are pretty similar.
Yeah, okay. For them to be bringing all that energy back in.
Yes.
Okay.
Next slide. Now, this is what we measured between Brodie VK7MO and myself.
Okay.
The red decodes on 6 metres, of which there were 829.
Okay.
And the black decodes on 2 metres. Now, Andrew Cleverchuk did send me a nice chart, which unfortunately I must have saved on a different memory stick.
Okay.
But it showed very clearly that the peak of the aurora, the aurora became visible to Brodie just in about here.
Yep.
And then again over this period.
Okay.
Now, the reason I think that there's 6 metres decodes, well, that one was due to aurora.
Okay.
But the 6 metre ones, when there's no 2 metre ones, I think are meteor scatter.
Right. Okay.
And they don't have as much Doppler shift.
And you think this one's aurora because of the spreading?
Yes.
Yeah. Okay.
And particularly because the spreading on 2 metres
is matching it.
Is matching it.
So, sorry, correlating with it.
Yes.
Yeah.
Now, on 6 metres, there's certainly a bit of Doppler there, which sort of equates with this, but the ratio is not 3 to 1, which you would expect.
Yeah.
But we've found that this lot here and that lot there, they are about 3 to 1.
Yeah. Okay.
And I think the reason it depends very much on where the aurora is, because my beam width on 6 metres is much wider than on 2 metres.
Yep. Yeah.
And I think you're dealing with different parts of the aurora, which is why you get different amounts of Doppler.
Okay.
We'll go to the next slide. Now, this was the signal to noise ratio on 6 metres compared with 2 metres, and 6 metres got up to plus 10 dB on the WSJT scale. And that's a very strong signal.
You would have been hearing that.
Oh yes, except that I was transmitting it. We don't sort of spend all night. We go to bed and we just record this data, and Brodie then sends it to me in the morning.
I'm disappointed. I'm disappointed.
Well, often we set this up and nothing happens, you see. So,
no.
yeah.
Okay.
But if I got Brody to send me the files, then I'm sure I could hear it.
Yeah. Okay.
So
6 meters got up to +10. 2 meters, what was -4
or something like it. Yes.
And -4 is that's still
A very strong signal. Yes. Yeah.
And that's okay. And so, any explanation for this sort of variation for this, or because there are
well,
big...
I think there's a lot of factors that cause the variation.
Okay.
One is the intensity of the aurora.
Yep. Okay.
And other factors are antenna beam widths and whether, when you get an aurora that, in this case, went over my head.
Yep.
In Tasmania, still nicely in Brody's beam width, but
no.
Probably on a minor lobe on my antenna.
Yeah.
So that is it for that event.
Okay. Well, and so I suppose any unique learnings from this one that adds to the knowledge pool?
Let's go back one.
Okay. Yep.
You'll notice that in general, the aurora before magnetic midnight is positive.
Yep. So this line's magnetic midnight.
Yes.
Yep.
And after it is negative. But there's a few up there. Now, Andrew did try and calculate the Doppler from auroral data, which he gets from NOAA.
Okay.
And while it didn't happen quite at that time, there was evidence that the aurora itself must have been moving very rapidly towards us.
Okay.
And could have been the reason why that positive Doppler was happening.
Okay.
And that's the first time we've seen that since we've been doing this stuff.
So you've got positive Doppler, so part of it is moving towards you, but some of it's moving away from you. Is that the explanation of that?
Probably, yes.
So it's just a really complex picture.
Yes.
That's the bottom line.
Yes.
There's lots going on in that space.
Yes.
Okay. No, okay.
I mean, even back here, there's some negative aurora.
Oh no, when there's positive, well and truly. And if that, you're saying that is aurora, that because of the spreading. So
yes.
you've got quite a bit of positive, but you've got a little block of negative down here. So yeah, okay. Well, there you go. I love it.
Okay,
Good stuff.
That finishes me.
I'll give you that. If you can grab Steve for me and bring Steve in, and we'll just just hang on. No comments at this stage. So if you've got any questions for Rex, drop them in the chat, and we'll get them to Rex and see whether there's any answers.
Okay. See ya.
Thank you, Rex. Thank you very much. Okay, so the next segment is an interesting one. I was talking to Steve. Now we'll get Steve VK7MO in the studio. I was talking to Steve on 3.4 gigahertz. So we've got a little segment of 3.4 gigahertz that we can still use. And I was talking to him along with Martin, VK7GN, on last Sunday morning, and we started to talk about a whole bunch of things. But one of the things is Steve spent time as a service person or a serviceman, and so that raised a whole lot of great stories on our 3.4 gig talk. Hello, Steve. Justin. Excellent. Yes, put that up there, and we'll And so I put together a little segment around a great column which I'm sure many of you will remember, or there will be equivalents in probably in America and also in New Zealand. So we'll put together a little segment around that. But first, I asked Steve, hello Steve.
Hey Justin.
To bring in, Steve's been working on a position indicator for his 6 metre beam.
Yeah, 6 metre beam, yeah.
So
and this is the junk box project.
Love
All the way from start to finish.
love it, love it, love it, love it.
Yeah.
So tell us the arrangement with the beam and the other various.
Okay, so I've got a very expensive tower with a very expensive hex beam on top of it. I pretty much paid through the nose for it, but I'm very happy with it.
Okay,
so
cool.
Not worried that.
Yep.
But that was kind of like, that's a big budget.
Okay.
And then I suddenly goes, well, I've got 6 metres on the hex beam, but I would really like a more powerful 6 metre antenna, and I'd like to also aim it independently of the hex beam.
Okay.
So the hex beam's nearly always facing north, but I want to be able to go other directions with 6 metres. So.
Okay.
But then it's like, okay, I've got to do this on a shoestring now because run out of money.
Yeah.
So
It does tend to focus you somewhat, yes.
Yeah, so my kind friend Murray ZMS said, oh, I've got a TV rotator you can have. And it's like, yeah, okay, fine. And he brings in this dodgy looking piece of equipment. It is, it doesn't look nice at all. And
just keep going. What's that on?
oh, you tell me. So anyway, this.
Okay, keep going.
This is an old television rotator, and it's. He only gave me the rotator. He didn't give me the controller.
Ah, okay, right.
And he says all you need to do is just plug 24 volts AC into it and put a capacitor on there, and it'll work. It's like, yeah, right. So off I go and I start mucking around with it, and sure enough, if you put the right size capacitor in there and run it off 24 volts AC, and then I'm just running it off this little plug pack.
Yep. Yeah.
Which is like a garden light power supply.
There you go.
And it works. I've since realised that you need to put a reasonable size capacitor in there, because if you don't put a big enough one in there, it just dies.
Yeah.
And eventually the thing stops turning.
And it's the capacitor that is changing the phase to get the direction.
Yeah, so the motor is, there are 3 wires connected to the rotator.
Yep.
And one of them's ground.
Yep.
And you put power on one or the other 2, and there's a capacitor in between those 2.
Okay.
And so depending on which one you power, as to which direction it goes.
Yeah. Okay.
That's pretty straightforward. So yeah, okay.
Nice.
So right now I want to be able to operate this thing from anywhere other than at the bottom of the tower, because that's pretty much what I'm doing at the moment, which usually means staring into the sun whilst I'm trying to turn it in the right direction. And of course the complicating factor is that this is not mounted on top of the tower. It is mounted on the side of the tower, and there is another antenna on the same tower with another rotator.
Right, so you've got an interference factor here.
So you cannot turn it 360 degrees. You can only turn it from roughly northwest to just south of east.
Okay.
That's your limit.
Right.
So you've got to not hit the other antenna in the process, because if you hit it hard enough, it won't do any damage, but then this motor will jam.
Correct.
And then you've got to tip the whole thing over to fix the problem. So it's like, that's not very good.
Yeah, okay. Right.
So, okay, 2 problems. One is I've got to be able to not turn it too far.
Yep.
I've got to be able to operate it from within the shack, in other words, know where it's pointed.
Yep.
So I'm thinking of all sorts of weird things. So I came down and had a look at, remember seeing your design with your magnetic loop, where you just simply had a drive belt on, and you had the position indicator off to the side. That's simple and it will work. So into the junk box, I've been collecting bits out of old dot matrix printers for years.
Yep.
Including entire carriage rails with motors and cogs and belts and everything.
I love it.
So I said, yep, fine. So all I got the belt and the cog, and so I played with it for a bit. So I just wrapped the belt around the shaft. So that's slightly smaller than the size of the cog.
Let's zoom in here a little bit. Okay, there we go.
So this is slightly smaller than this cog that's in here.
Yep. Okay.
And that will then mean that a full turn on this sorry, almost a full turn on this is the limit of the range of the potentiometer underneath that cog. So
that's handy.
It's a reasonable, nearly a full turn, which is pretty good.
Great.
But of course, I only need from northwest to south of east.
Yeah. Okay. Righto.
So I put a couple of micro switches on there.
Yep.
You can see there's 2 micro switches, and I put a single screw into the edge of the cog, which, mind you, it's on a bit of nylon to give it strength.
Yep.
And that single screw
Just
would
go
then
that way a bit because it's gone out of focus. Just go this way.
right.
There we go.
Yeah.
And it's
Okay.
back in focus.
So we turn there's a single screw in the cog anyway, so that when it gets to those limit points, which we knew where they were, it will then operate the micro switches.
Okay. Okay. Cool.
And each micro switch is in series with one of the phases, so that if you're powering that phase and you get to the limit, the micro switch will cut the power. You're still able to power the other phase.
Yeah. Okay.
So very simple idea, and it works.
Love it. Love it.
Then I think, but now I've got to stay within this restriction of northwest to just south of east.
Okay.
How am I going to do that? And the obvious thing was to put adjustable stops on top of the cog.
Yep.
And I initially was going to hang them over the side of the cog, but then if I hang them over the side of the cog, they're going to interfere with the belt.
Yep.
And we were having a conversation about this last Sunday, and it was like the penny dropped. So I just make bigger flags on the micro switches.
It's spot on.
And they were hand cut. These flags are hand cut. So I just made bigger ones.
Yeah.
And
I
now I
it.
don't have to hang it over the side.
Yep.
So it now is yet to be tested.
And to adjust it, basically, you're bending the
because they're fixed mounted, but they're kind of zigzag.
Yeah.
And so you can just bend them with a pair of pliers.
I love it.
Into pretty much any position you want within about a 30-degree arc, which is more than enough because they're roughly in the right place now.
Yep.
But I just need to. Yeah. So those are those 2 bits of metal sitting on here. They're a bit difficult to see. But there's one there and another one there.
Great.
But once it's on the tower, then I can fine tune it. But I know that they're roughly in the right position.
Cool.
Now.
Cool.
And that's it. So the antenna sits on here, and there you go. I've got a piece of plastic which is, because this needs to be weatherproofed.
Okay.
So that will fit over the top of that won't go over the
very
motor,
nice.
that's not quite round.
Yep.
But go over the top. I've just got to work out how to attach it, but it'll just sit over the top and weatherproof it. It's not going to be spider-proof, of course. So.
No.
They're still going to need that kind of maintenance.
That's all right. You'll squash the spiders when you go around.
Until they get in there and muck up the switches.
Correct.
But at least it'll be watertight, and that's the important
At least you've got a weatherproof cover. I haven't got mine. Mine won't yet.
Yeah. Well, I'm thinking ahead. I mean, I build things. My engineering ethos is I build it once and it works, and I put it in the air and it never comes down. Yeah. That's my ethos. Yeah. So I've put a lot of time and effort into making it in the first place.
I love it.
And to my satisfaction, that it's going to be more than strong enough to stay there.
Yeah.
Or more than watertight or whatever it needs to be. I mean, some water's going to get in there, but it doesn't matter. It's just going to go straight down onto the normally exposed area of the rotator anyway.
Yeah.
I only need to protect this area here.
Correct.
So, and this is all protected. So this is a die-cast case. It's not watertight, so I've put a piece of plastic over it just to make it more watertight, water resistant, not watertight. And all it needs to do is a bit of airspace at the bottom where cables go in. Yep. So it will self-dry even if water does manage to get into it.
I love it.
But it's only got a potentiometer in there, so there's not much in there. And hopefully it'll be good. And I'll be able to operate the 6 metre beam from inside the jack and see where it's pointed.
It's fantastic. And we'll get you a Arduino LCD position indicator.
Well, I was thinking junk box. I've just got an analog meter. And
okay.
Because this is only a potentiometer in there, so it'll
just a voltage. Well and truly. And
I've just marked north, east, and
I love it. That's even better.
I don't need to.
And can I just say, because you don't have, this isn't exactly the same size as this, you can do that calibration on the meter. You don't have to do you don't have to do it in software.
Yeah.
Which is what I'm having to do.
Oh, okay.
Because I've gone down a whole rabbit hole here. There's I thought I've got an analog to digital scale, which is 0 to 1023.
Yep.
which is the voltage, and then you've got your position indicator, which is 360 degrees, potentially. Now, 0 to 1023 versus 0 to 359. And I went down this rabbit hole of linear interpolation, which is just, it's algebra, I know that. And I thought, okay, and I'm going to try and get the Arduino to do this on the fly. Well, of course, the Arduino just goes, so I'm having to use lookup tables.
Which makes more sense, really.
Correct. And you can then make it anything, which is great. But the problem is, as soon as you put like 1024 times however many values, you run out of space in an Arduino real quick.
Ah, right. Okay.
So you're having to go to the next level of Arduino, just so that you've got enough memory.
Or write better code.
Or speed it up. So there's that sort. There is that sort of aspect.
But I mean, I'm just going to be quite dumb about it. I don't really care.
No. I love the meter.
Something I can look at and pointing in that particular direction.
Correct.
And I've marked on there with a pen
I love
north. That'll do.
I love it. Absolutely.
That will do. And a switch. And it's just a little rocker switch.
Yep.
That just centre off, left, right.
Done.
Or east and west, whatever you want to call it.
And it doesn't have to be, in this particular case, it doesn't have to be super duper accurate.
Well, it's never going to be super duper accurate. So even though I've got a tensioner on that belt, there is a certain amount of slack because as it's turning, the belts are overlapping on the post here. So when they stop overlapping, the relationship changes and that just tensioner changes, and it'll pull the pot a little bit.
Okay.
So there'll be some non-linearity in it, but hopefully it will consistently give me the same point when I point it in that direction. And if it doesn't, I can just go out, oh yeah, that's not quite north, I'll go back in and make another mark on my little meter.
I love it. Do it in pencil so you can rub it out.
I'll just take the cover off the meter and leave it off.
I love it. Fantastic.
So
Thank you, Steve.
No problem.
I absolutely love it, and I absolutely love the fact that it's all from the junk box.
It is, except for the screws, obviously. But the screws I had already. I mean, everything was already there. But it's 100% junk box project.
And a printer, a dot matrix printer, or some other printer was sacrificed in the making of this device.
Well, it was sacrificed many years ago.
Yeah. Okay.
So that's been in the junk box for a long time. So it sort of broke my heart to take a complete mechanism, which was the motor and the belt and the idler pulley, and cut it all to pieces.
No.
Because I needed the brackets. And
it had its day.
It did. But it's working.
I absolutely love it.
And the piece de resistance is the device that keeps the belt in place on the other side there.
Yes. Well,
so there'll happen to be a handy hole in the pipe.
There we go.
And the right device to put in that hole was a clout.
There you go.
I love it. It's just the right size to keep the belt in there, and then the belt rides over the top of the clout to make sure that doesn't fall out.
Okay.
It's pretty simple, really.
I love it. I absolutely love it.
No screws or anything. We don't want to damage the belt, so it's just a clout. And it's just the right size for the hole.
That's all you need.
It is.
That is well and truly all you need.
It is. And you just use what you got.
Oh, I love it. Yeah.
And even a bit of Cat 5 to.
That's actually Cat 6, which is a really bad choice of cable to use. It's solid core Cat 6, and in the process of trimming it and installing it, 2 of the wires broke, and I've had to fault find those wires. One of them's just here that had to resolder, and the other one inside I had to resolder. So it's like, if you're going to do it with cable, use multi-stranded Cat 5, not Cat 6.
Yeah, well and truly.
It's a really bad choice of cable, and once it was in and I figured the problem, I thought, no, I'm not taking it back out, I'll just fix it.
I love it. I absolutely love it. All right. Okay. What we might do, we'll put that down on the chair.
Yep.
And now, the other, as I mentioned earlier, one of the things that Steve and I and Martin, VK7GN, were talking about was the serviceman's column. Now, that put me down another rabbit hole today. So, I suddenly realised, to give a bit of context around this particular particular segment, I needed to actually show you a bit of a progression of electronics magazines.
Ah, yes.
in Australia. So this is a bit of a history. Oh, hang on. Isn't the run capacitor trek the same with the Yaesu 5500 as L things? Yes. No, exactly the same. What's the choice? The cable choice for rotator, etc., for an irrigation solenoid multi-core. Well, can I suggest something here? A bit of there is some very nice multi-cord security cable.
Yeah.
That you can get in a variety of sizes, so current carrying capacities, and you can get them in 6, 8, 4, 6, and 8 core. Available from Joker. So that's one of the areas. If you need high current, and most of that sort of size, you don't need that high current.
That one.
Yep.
I'm currently using two pair telephone cable, which is really lightweight.
And Andrew, yes, yeah. I suppose trailer light cable would as well. The only problem with trailer light cable is you need the one that's got lots of cores in it, not just the 4 core or that sort of thing.
I'm only using. Well, I'm going to have to go to 6 core.
Yeah.
Sorry, it is 4 wire cable, so it's 2 pair.
Okay.
You only need 4 wires because you've got the ground.
Oh, it's the common.
Ground and common. So you've got that common with the position indicator. Yep. So 1 wire coming back from that, and 2 wires to the two phases. That's it.
Yeah.
4 wires total.
No.
So I'm going to continue to use that telephone cable.
Yeah. Okay. Well, there you go.
It's about 12 metre run from there down to where the control panel is, and from there I'm going to use a relay control system back into the shack.
Okay.
So it'll be that way I'll have 2 points of control, one in the shed and one in the shack.
Okay, cool.
Yeah.
Cool. Fantastic.
So
all right.
Power supply is.
So what I thought was here, I'll give you a bit of a very quick history lesson on the magazines, the electronics magazines and hobby magazines that we're talking about, and then we're going to dive into a particular column that's in those magazines. So one of the key amateur radio magazines was Radio and Hobbies. Now, Radio and Hobbies started in around April 1939. That's this one here. In fact, that's an even better picture. In fact, hang on, that's an even better picture, which if we go to there... hang on, that did absolutely nothing. Why did that do absolutely nothing? Oh, because I'm going to exactly the same place. Okay. That helps.
Does the audio still work?
Yeah, no, we fixed that problem. We did fix that problem.
Oh, good.
So Radio and Hobbies was born out of a magazine called Wireless Weekly, which started in about 1922. The key thing with Radio and Hobbies was the first editor of Radio and Hobbies, and the editor who was from 1947 through until 1960, was a person called John Moyle.
Oh, okay. There you go.
And a couple of weekends ago we had the John Moyle Memorial Field Day, and so there's a bit of amateur radio history in there. So it was Radio and Hobbies, and the fascinating thing about Radio and Hobbies is we actually had, if I just open up here, and go to the right mouse. So that particular, this is Radio and Hobbies, and this is the first edition, pretty ratty first edition, but it's April 1939. It costs 6pence, and I just thought I'd show you this because it's Radio and Hobbies. Hobbies.
So there's a bit of knitting in there, isn't
there? Well, no, there's all sorts of things. There is the radio side, so popular sets, what band, variable selectivity, transmitters, a high frequency buzzer for code practice, how to use a file. simple
okay.
hints.
Yep.
Shortwave pages, test loudspeaker, about screens, the movie camera pages, capture the moment. There's a photography page. There is even a magic page by Barry Kent, the magician.
Oh, okay. Yep.
Who builds model aeroplanes, sharpening shears, repairing faulty gas taps, air guns and rifles, notes on shooting.
Oh, right. Yeah, okay.
So it was definitely radio and hobbies, which is absolutely fascinating.
With a very strong male
Oh,
focus.
correct. So then we went up to February 1955, and I'll just open up February 1955. Sorry, it became radio, television, and hobbies.
Yeah.
So obviously in 1955, 56,
And the price was 5 times a
oh, hey, 2 shillings and sixpence. Oh my God.
5 times.
So television, went up,
Yeah.
but still radio, television, and hobbies. So it was still still a hobby magazine. Now, one of the interesting things here, Neville Williams. Now, hold that thought, because Neville Williams was editor at that stage, who was VK2XV. There were lots of amateurs who were involved in this. Jamison Rose, another name that jumps out at me there. And so Blue Streak, which is what they were testing at Woomera.
Yep.
The Blue Streak rockets, and there's a bit of an insight into Woomera, etc., etc. This is February 1963. How now made in Australia, the 6166 linear power amplifier. So this is a valve lasers. So this was which was pretty earth shattering in 1963, etc. So it then became television and hobbies. It then became in April 1965, it became Electronics Australia. So now in 1965, Electronics Australia, and I've literally just grabbed a
random
copy, which is October 1980.
Oh, really?
October 1980, it was a digital engine analyzer, a do-it-yourself atomic bomb, a stylus timer, and a battery monitor. So,
do you remember Dick Smith used to have in his catalogue a kit for an atomic bomb?
Oh, did he?
Yes, he supplied everything except the uranium.
Oh, okay.
And it was astronomically expensive. But
yeah.
He would supply a 2-story building and show you how to convert that building into a bomb. It was a joke, of course.
I love it. It's a bit like, look up in the J-Car catalogue, they sell flux capacitors. Very expensive, and I think they're out of stock right at the moment, but they sell flux capacitors, so there you go. You too can go back to the future. So that was April 1965, it became Electronics Australia. Now, in Electronics Australia, there was a segment called The Serviceman.
Which I loved that.
So that's one of the reasons and how we got to where we got to.
Well, if you bought Electronics Australia, that was the first section you read.
Correct.
Straight to it.
And I've got a few examples here. This was intermittent colour television fault. This is in 1977 on aerials, feeders, and exorcising ghosts.
Yep.
And that was December 1977. Then this one was actually on there was a bit about CCD arrays and in video cameras and all sorts of things. Mm-hmm. Not So Elementary, My Dear Watson, and that was January 1985, and that was about a Chrysler 660-3 colour television chassis. So and then I dug out because in Electronics Australia went through until December 2000. There was 432 issues.
Yep. Yep.
Went through to December 2000. And I didn't know this, but it then became Electronics Australia Today.
Yep.
There was only six editions done, and then it failed in April 2001.
So electronics, there used to be another magazine called Electronics Today.
Yes. Yeah.
So that would have been the amalgamation of the two.
ETI, which is Electronics Today International,
Yeah.
that was a competitor for EA.
So I think they amalgamated, didn't they?
Oh, in the end. The end. Now, the thing
And
about...
the sad thing about Electronics Australia when that last era happened was that it stopped being a technically focused magazine to becoming a review magazine.
Yeah.
And the difference was dramatic.
Yeah. And I think that's what probably ended it.
Well, I read one article. The Serviceperson wasn't there. The circuit narrator wasn't there.
Yeah.
All the things you wouldn't technically want to read weren't there. It was just all review.
Yeah.
And I contacted them immediately. I said I want my subscription cancelled and I want my money back on this issue, and they did.
Yeah. Okay.
Yeah.
Cool. Now, ETI. The key thing about ETI. So this was at the time was a competitor to EA. The editor of ETI was Roger Harrison, VK7MO. So there you go. There was also Australian Electronics Monthly, and also Talking Electronics was another one at the time. And I've got a couple of editions of those that I've kept that have some interesting articles in them. Silicon Chip came onto the scene. Leo Simpson was the editor. Now Leo Simpson was EA. They came into existence in 1987, and they're still going.
Yep.
And in fact, they continued. The Silicon Chip became the Serviceman's Log, and this is a Silicon Chip of June 1991.
Yep.
Just one I picked up at home because I actually built. This particular edition has a high performance UHF TV antenna, which I actually built.
Oh, okay.
When UHF TV became a thing,
Mm-hmm.
but it shows the Serviceman's Log, and it's 3 or 4 pages. It's
the Serviceman's Log featured reader contributions.
Yep, correct.
So it wasn't just one person writing the log.
Yep.
It would take lots of different people's articles and present them.
And this particular one, it's interesting because a lot of the ones that were in EA, the examples that I found, it was a particular problem, and he stuck on that particular problem.
And he would, but the thing is, he would detail
do it
the
in
circuit
detail.
in
Correct.
such detail and completely explain how the circuit works. So you learn things.
Yeah.
You learned about circuits.
It included circuit diagrams and all sorts of things. So
you'd sit there and you'd follow it, and you would understand the circuit as he was describing the fault. It was pretty cool.
And I suppose that was it wasn't only the fix, it was how he ended up with the fix.
And how it worked, how it was meant to work.
The journey, yeah. So, so that was the discussion that we had on Sunday morning on 3.4 gigs. Now, just before we go on, I found in my looking Silicon Chip. This is
the way I see it.
It's not the way I see it by guess who? Neville Williams.
Oh, okay, yeah.
Neville Williams, and this particular edition, which I think's in the late 1980s. Look out, TV Servicemen, VCRs are now disposable.
Oh.
So an interesting article, and by the radio and electronics, the radio and hobbies editor, Neville Williams. So the sort of same group of people,
Yeah, that's right.
same group of people were all doing these articles. So what we thought we'd do is a little bit of we've done our rundown memory lane. And so I thought what I'd do is hand over to and we just have a bit of a discussion about the because Steve has actually spent a fair degree of his working life.
Yeah.
Correct me if I'm wrong. As a serviceman.
I've been had a technical role right from my first day of employment.
Okay. Okay.
Because here's the weird thing: my first day of employment was as an electronics expert in an otherwise mechanical workshop,
Oh, okay.
and I was
Cool.
straight out of school.
Right.
So
Okay.
no apprenticeship. It's just you're now the expert. You have to. Right, really? Oh,
Yeah,
great.
okay.
Show me
Right.
show me how this works.
Okay.
So yeah, I got a brief amount of training, and then it's like now I'm in charge. It's like
Yeah.
wow. It's like,
Okay.
and I was the only person doing electronics in that otherwise mechanical workshop.
Okay.
So yeah.
Yeah.
So I realised many years later I never ever did an apprenticeship.
In the deep end. Oh my god.
Oh, it was fun.
Well and truly.
It was fun, and my piece de resistance was the first major fault that we encountered that I came up with a solution fairly quickly. So I was pretty happy with that, even though it was a simple fault.
Yep.
Finding it was always the case, and you've got to find it.
It's well and truly.
And you think with electronics you've got to test components and you've got to look for broken connections, all this sort of stuff. No, you don't. You just got to look at it. You just got to look at it. I mean, this was a case of the particular piece of equipment had an op amp with a photo sensor.
Yep.
And it was just literally reading the images on a page.
Yep.
At a fairly high rate, and converting that into electrical pulses, which were then used somewhere else in the circuit.
Yep.
And that section was failing. It was just not working properly.
Okay.
So first thing you do is I take the covers off, gain access to that part of the machine, and just sit there and look at it.
Okay.
And on the back of the op amp is a compensation capacitor that goes on pin 5 to ground.
Yeah.
In the earlier version of that particular circuit, they used capacitor with a little plastic packet. I'm not exactly sure what they were. It might have been a Mylar or something like that.
Yeah, MKT or something.
Yeah, but it was encased in plastic, and they were reliable capacitors.
Yep.
But this revised version of the circuit just used a ceramic.
Right.
Nobody thought anything of it, except when I took the case off and had a look at it. This ceramic looked like it was sweating, and it was actually sweating. It was
Right.
sopping wet.
Yeah. Okay.
It's like, okay. So I swapped it out with the original value capacitor.
Yep.
Problem vanished. It's like, and this was beginning of a major problem right around Australia because these things were failing regularly.
Yeah. Okay.
And I just happened to be the first one to spot it.
Well,
So
there you go.
There you go. And it's like, it was a simple fault, but it was just a matter of looking, observation.
Oh no! Hey, tell us about the PC that was full of particular items.
Yes. So my first job in Tasmania, because I'd spent 10 years in Sydney fixing duplicating machines basically.
Yeah. Okay.
And photocopiers in
Yep.
the end. But my first job in Tasmania was to service computers.
Okay.
Specifically IBM computers.
Okay.
The genuine IBM, not the
Yep.
knockoffs, not the compacts and NECs, whatever,
Yep.
but the
Not
genuine
the
IBM.
clones.
Again, the day after I started work, they sent me off to Melbourne to learn how to spell IBM, but I knew absolutely nothing about computers. I mean, I didn't, not that I didn't know anything about computers, but I knew nothing about IBM. I had no knowledge on it whatsoever.
Yeah. Okay. Big Blue.
So anyway, they literally sent me off to Melbourne the next day to learn how to spell IBM.
Yep.
And I'm sitting in the class, and there's all these people that know how to use it, and the instructor says, oh, if you ever get stuck, just press Control-Alt-Delete and go back to the start. Do you think I can get Control-Alt-Delete to work?
Okay.
Because I was hitting Control-Alt-Backspace. And I was too embarrassed to say, hey, I can't get this to work.
Right.
So I just quietly reached down and switched the machine off and turned it back on again. Anyway, so getting back to this particular incident, we're talking about the early days of IBM PCs where you had the PC XT and the PC AT. The
Yep.
8-bit version and the 16-bit
Yep.
version.
Yep.
So that's when I started with IBM, so
Okay.
way before the PS2 era.
Okay.
So the IBM AT was fairly new on the scene. But of course, our patch had lots and lots of XTs out there.
Yep.
And the XT in the most basic form was 2 floppy disks.
Yep. 2 5.25-inch floppy disks.
2 full height 5.25-inch floppy
Yes,
disks, which
correct.
had a sort of flip
Now,
core.
can I just say I did look for my 5.25-inch discs, which are somewhere safe because I couldn't find them.
Yeah.
So I did try and look for the 5.25-inch disc. I did find the 3.5s,
And I forgot to bring the 8 inches in. Anyway.
but I'll find them and I'll bring them in.
So the most simple form of the IBM XT had 2 5.25 inch floppy disks.
Full size, yep.
What's the capacity on those? 360 kilobytes?
It's 360 kilobytes.
Well, it might have been 320 because some of them weren't quite the same.
Yeah.
But
Okay.
anyway, or you could have a floppy disk and a hard disk of maybe 5 megabytes. And that was full hot as well.
Yeah.
Weighed a ton.
Yeah.
But anyway, but the construction of these boxes is very strong.
There's
And
steel boxes.
They had 8 expansion slots, and they had, you could literally sit the CRT monitor on top of the computer, not a problem because it was strong.
Yep.
But it had the top was slide off.
Yep.
5 screws on the back to get it off.
Yep.
So my usual habit when I got into service and machine was I'd take all the plugs and things out the back, I'd tip it up on its front and undo the 5 screws, lay it back down again and remove the cover.
Yep.
Well, I get into this particular office and the complaint wasn't, the computer wasn't working, wouldn't go at all. So I tip it up onto its front. All I could hear was
Not good.
the sound of 1,000 bits and pieces rattling around inside the machine. I thought, what on earth is that? Now, we're talking about full height 5.25 inch floppy disk drives, which had the kind of a flip up door.
That's right.
They were never fully sealed with the door open or closed. Didn't matter because even with the door closed, there was still a bit of a gap where you get your finger in to flip it up. When I did get the cover off, the reason for the sound was there was a full-on mouse nest or rat's nest in there. And that was the problem because they'd peed all over the board and they'd done untold damage to it. There were components. There was mind you, all the memory chips and everything were pluggable.
Yeah.
So you can unplug them and plug them again. I think we had to replace a handful of them and maybe repair something else because the pee is corrosive.
Is acidic, well and truly.
It eats away copper.
Yeah.
So anyway, so that was what was wrong with it. It was just full of mouse poo. And it turned out that the floppy disk drive is a convenient access hole for a mouse. I'm not sure about rats, but mouse.
It'd be a mouse, I reckon.
You could quite easily get in and out through that.
Yeah.
Through that opening. So I ended up saying to the customer, I said, you're going to have to put a floppy disk in there and close the door just to keep the mice out. All the time.
I love it.
Because it's like, wow, it's like, and that's just one of those things. It's like, in that case, I didn't need to look. I knew straight away there was something seriously wrong with this machine.
Well and truly, it shouldn't be making that noise.
Now PCs are amazing things. I mean, they environmentally they will work almost anywhere.
Yeah.
Now EZ over in Risdon,
yep,
they're known for fairly toxic sort of workplace.
As in corrosive.
Not in terms of culture, but in terms of what's there.
Correct.
I mean, I've walked through there to go to service a printer, and there's been like blue liquid on the ground, and I'm going, I'm not walking in that. I don't know what it is. Oh, that's just rainwater. I said, well, why is it blue? You know, you get to the printer and they say, then what happened to it? Oh, a bit of rainwater got in. Yeah, sure. It's eaten away the copper. It was pretty strong rainwater. But there was one particular IBM, this time an PS2 machine, which used in their process control, and it sat inside an environmental enclosure. So the environmental enclosure was meant to keep the computer safe.
Yeah, right. Okay.
Every 6 months, without a fail, we'd be there replacing the floppy disk drive.
Right.
Because it had failed.
Okay.
Even though the environmental enclosure was closed. But obviously they had to open it, put discs in and out. So God knows what was on the discs when they put them in, but and I've had other situations where you look at a computer and you look inside it and it's just not working properly, but oh yeah. One case was in an office near the return air duct in the building. Yeah. And it just happened to be that was where all the dust in the building collected.
Yep. Yeah.
And computers will suck in dust.
Yep.
We all know that. And it generally doesn't cause a problem. But sometimes, just sometimes, the dust might be conductive. Yeah. And that happened one time. I just, we cleaned all the dust out and the computer worked fine. Okay. Another time I took a computer out of a hardware business in the back office, open it up, and it looked like a lunar landscape. It was just completely grey. But you could see the shape. You could see the shape of every component on the circuit board, and it was working fine, mind you. Yeah. But you could just see it was just like a lunar landscape, and this was concrete dust. It was perfectly grey. Yep. Perfectly. It was just like it had been settled like a layer of snow. And it was like turned upside down, bang it all out, And I've had other situations where you go to a machine, it's like, oh yeah, there's a bit of dust in there, take it outside, bang it upside down on the ground, literally, and unbelievable amount of dirt comes out of them. Put them back in, they work. So, and it's like, that's pretty extreme when you're doing things like that. It's like, yeah, but they're not doing proper maintenance in the first place. It's like
industrial environments, well and truly.
Yeah.
Yeah,
So,
yeah.
it's like, whoa.
Okay. Okay.
Yeah.
No. Well, there's a couple there's a couple of examples I can give as well.
Yes.
I used to be similar situation. I ended up as a product support manager in the company, the manufacturing company. So we were actually manufacturing interfaces for Triumph Adler Daisy Wheel typewriters.
Yeah.
So that was the first one. We then went to a word processor that used a Daisy Wheel typewriter as the printer and the keyboard.
Yep.
So and that had full height 5 1/4 inch drives.
Yeah.
The whole bit, and then we went to half height drive, and that was pretty impressive, all that sort of stuff. But then we went to, and we actually did start to produce our very own PCs,
Yes,
IBM clones.
Yes.
I
blew one of them up one day.
Oh, there you go.
That's another story.
That's another story for another time. But we had one of the things we had was and we thought this was pretty innovative, I suppose you'd say. It was a thing called a soft BIOS.
Yeah.
So instead of having and in early PCs there was quite a bit of, if you wanted to use different interface cards and all sorts of stuff, it sometimes involved a BIOS update, and the BIOS was held on EEPROMs normally. So to get over this issue, we had what was called a soft BIOS. So it would boot, the machine would boot, would use the EEPROM to boot, and the first thing it looked at on the boot floppy disk was a updated BIOS image.
Oh, okay, yep.
Which it then loaded into memory and would then use that particular BIOS, which got over a lot of problems for us. But we had a service where we said to people, if they sent us a copy of their disk and the copy of their disk was so that we knew it was a bona fide our machine and all of this sort of stuff. They weren't just sending us random disks.
Yep.
So we had a service where they sent us a copy, we'd update it, and then we'd send it back to them, and they could update. So we get this letter in the mail, and we open it up, and it's a photocopy of the disc. And we looked at this and went, well, technically it's a copy of the disc. And so we sent out an actual floppy disk, but it was just...
That's hilarious.
Oh, just...
Can I quickly tell you how I blew one up?
Yeah, go.
We have one... We're talking about the... what's
The microbyte.
Microbyte.
Yeah. PC 230 or HC 120, or there's a few other models.
Yeah, well, it's a smaller one anyway.
Yeah.
But we had to set up in the workshop just to allow us to access BBSs, because we had no internet those days, so it was all BBS.
Yep.
So we had put it all together, set it up, and we had a keyboard on it which was not a genuine IBM keyboard.
Okay.
It was just a third-party one, but it had like a metal case.
Okay.
Not a plastic case, but it was a metal case.
Yep.
And this is all set up and working fine, no worries. I walked up to it probably the day after I set it up. Went to touch it, and a spark jumped from my finger to this metal case that the fella on the other side of the workshop heard. So it was quite a decent spark, and geez, it hurt. And the computer rebooted. Wow, that's bizarre. And then seconds later, a mountain of smoke poured out of it.
Ooh, okay.
And yeah, that's right, the modem rebooted as well. But it's like, right, well, that's toast.
Yeah, okay. We probably saw that back in the service
I think it went in the bin. Because it wasn't a serviceable unit, was it? It was like
I love it.
Almost an all-in-one computer. And it's like, wow, it's like, that lasted literally a day.
Now, some of the... I was trying to think about some of the other circumstances where I've had to troubleshoot and do difficult troubleshooting.
Yeah.
And one of the ones that I couldn't come up with any specific. Oh no, I know a specific example. One of the ones that I find particularly challenging is automotive.
Yeah.
And
I hate automotive electrics. I hate it.
no, because
I hate it.
there are so many paths in an automotive electrical, which, can I just say, a lot of electrical and electronic equipment rely on those paths, but you to try and isolate a piece of equipment, it becomes really hard.
Oh, okay.
And you need to take that into account. And the classic one was I changed over some globes to LED globes.
Yep.
Now that was fine, and I knew that there's not as much load, so things like indicator control units complain about it and all sorts. So got over all of that, but I had a joint parking light, so a brake light, which is a parking light and a brake light.
So it's a light globe with two elements in it.
Correct.
Yep.
Normally 2 elements, and that's fine.
Okay. Not this case.
On an LED light that does that,
Yeah.
I put it in, and I was only getting the brake light, and I went, oh. And so I actually literally physically took one of these globes apart, and I realised that there were 2 elements in there, but there needed to be a diode put in, so that it only went. So as the current's coming through on, so there's 3 connections effectively.
Yeah.
There's ground, and then there's the parking light, and then there is the stoplight. What you were getting was a path literally through the common of both of them that was lighting both of them.
Oh.
And I went, oh, okay. So I thought about this, and I went, well, if I put a diode in, and I think I put the diode in the parking side of it.
Yeah.
Bingo, it was fine.
Oh, okay.
But I just sort of looked at this, and it was you're looking at that capacitor going, no, that's not right. That's actually not right.
Yeah.
So it was that sort of stuff. So automotive, I just find, and I full marks to automotive electricians. And especially with some of the 2-wire bus systems that are in cars these days. So there is literally a 2-wire bus that goes around the whole car.
Everything hanging off that.
And everything has an address, so it's like a CAN bus arrangement.
So that cuts down on the wiring.
Oh, well and truly.
Dramatically.
The loom becomes a 2-wire loom around the car and all of this sort of stuff.
Yeah.
Great. The other thing, there was a certain RF is another area where I find the complexity can go up, because you're not only looking at hardware and potentially software, you're looking at RF effects as well. Yeah. So, and I'll give you an example of one of those. I can't actually name up the network, but I can say that it's a certain emergency services radio network. They had an issue where they were getting all of these intermods to the point where and this is a digital radio network, those intermods were actually causing bit errors. They were actually causing data streams to fail. And they ended up finding, they put spec-ans on it, they put test equipment on it, they put all sorts of stuff on it. They ended up realising that this particular path was pointed towards a fire tower, and in the fire tower there was a transistor radio in the windowsill.
Oh, really?
Was it, the transistor radio wasn't on?
Yeah. But it was tuning something.
It was tuning something and shooting it straight back at them.
Oh, really?
They took the radio out of the window and put it behind some metal, and everything came right.
That is really touchy.
It just happened to be in, and this is what I mean about RF and those intermods and that sort of stuff. It's just, now, the last example, and how are we going for time? Okay, we're at the end, but the last one is I have a and if Tony VK7YBG ever watches this, he'll laugh, because he's the one who sold me this particular piece of equipment. This is a Tektronix 22 gig spectrum analyzer.
Yep.
Nice piece of kit.
Mm-hmm.
Very nice piece of kit. We're talking 1980s. It's that sort of era of spec-an.
Yep.
Really nice. But I got it home, used it, I think, 1 or 2 times, and then went to turn it on, and nothing. And I went, oh, what's happened? And I thought, okay, fuse is blown or something's blown. No, nothing with the fuse. So start taking it apart. And this is an era which is discrete components, so you can do a certain amount of servicing on it. And so I think I spoke to Tony, and Tony went, you probably got that era of spectrum analyzer has a real problem with tantalum capacitors.
Oh,
going
horrible things.
Bad. And basically shorting.
They do. They short circuit.
They short circuit. That's how they fail. And so I tracked it down, and I finally got to the point to say, the 15 volt rail is not there.
Yeah.
And the power supply was fine. Power supply off the spec-an was 15 volts.
Yep.
The power supply on the spec-an. So,
and there's probably 100 tantalum capacitors hanging off it.
there's probably a friggin' 1,000 of them. It's just, oh my God. So, fortunately, this is that era of construction where everything's in modules that you unplug.
Yep.
So, I went through one module at a time with a reasonably low resistance reading ohm meter. Stick that on the 15 volt line, and I'm literally taking each of these modules out and seeing whether they make any difference to that reading. Got to the point where all of the modules were out, and absolutely no difference.
Oh dear.
And I went, and the problem with this is the motherboard in this, where everything plugs into it, has also got tantalum capacitors on it. And of course the motherboard is integral. You literally have to take the whole friggin' thing apart.
Oh no.
And I went, this is too hard. I haven't found it. And I put all the modules back in, screwed it all back together, and I put it on a bench. And I went, I'm going to deal with this when I've got more patience.
Never.
But as it turned out, I plugged it in, and I went, wonder if there's any difference. Turned it on, and it's perfectly all right. Until that particular capacitor decides to fail again, which it will. But it's that sort of troubleshooting. And this is a known issue with that era and that era of tantalum capacitors.
Yes.
A lot of people go through and they literally change out all of the tantalum capacitors because it just is a known problem.
Of course it is. Yeah.
And the failure mode is short. It's not a fail open or anything. It's a fail short.
Or at least if it fails short, at least have a burn mark on it or something. But no, there's nothing.
No.
I can remember having a board that was not a particularly big board, but it had at least a dozen of those on there, and one of them was faulty, but
which one?
Look at it and see which one it was.
Yeah, and it's very hard to do that in circuit. So yeah, I have a spectrum analyzer back again, which is fantastic, and I've since used it. But oh my God! Now we've got I'm not following up on the comments. Moffat's Madhouse. Yes. Tom Moffat, VK7TM, lived up at Ferntree. Sadly no longer with us. But I actually ended up with Tom Moffat's kits.
Oh, okay. Yep.
So his Weatherfax kits, and he had a couple of other kits. I actually ended up with those through a sequence of events. I sent them off to EE Blog, to Mr. EE Blog, a little while ago, so that on Peter Parker's recommendation, which was good, Peter, because it got Tom Moffat back in the back in the scene.
Mm-hmm.
Andrew, I used to pass the IBM plant in Spango Valley near Inverkip fairly regularly, now completely flattened. Massive plant, 1.6 kilometre long with its own train halt.
Oh, really?
There you go. Oh, there you go. In
But they probably
the
didn't,
UK.
They probably didn't make PCs.
Oh, no.
They would
No,
have
no.
made other equipment.
Yeah, big equipment that needed a train stop. Simon Dwyer, I feel I was born too late. I missed out on all the fun. No, Simon, you're in the fun. You're in Fun Central. If you're doing automotive electrics, the Power Probe, cough or knockoffs from a favourite online vendor, so is worth getting. Well, there you go. Thank you, Andrew. Fantastic. Thank you for that. So we'll finish off. Now. We've been raving on for way too long. So just a reminder, there is still a warning, actually a HF fade out warning that is in place, and I thought this was an interesting warning because they don't actually do these warnings terribly often. But so the HF fade out warnings for the 27th, 28th, and 29th, R1, R2 with a chance of R3, which it rarely gets to, and it is actually probable. It talks about the MUF, so maximum usable frequency depression, HF warning, and the ASWFC shortwave fade out warning, HF warnings, are both current. Now, these two warnings, if you actually read, one warning is telling you to go up in frequency,
Yep.
and the other warning's telling you to go down in frequency.
And the reality is nothing works.
So, shortwave fade-outs degrade lower shortwave frequencies first through increased ionospheric absorption, and the usual strategy during shortwave fade-outs is to try a higher frequency. In contrast, during periods of ionospheric MUF, or maximum usable frequency depression, the upper frequencies are degraded first, and the usual strategy is to use a lower frequency.
Right.
So what you've got is advice to tell you to go up and down.
The reality is nothing works. So there's loads and loads of signals. If you're watching FT8 on bands between 20 metres and 10 metres, there's loads and loads of FT8, but it's not very strong.
Correct.
So if you really want to do something more serious, the signals are there, but they're just so weak.
They're well and truly, and it's really only FT8 type digital modes that
still work.
Still work. So,
but even so, 10 metres has over the last few days been utterly dead.
Yeah.
Not today, but previous days.
6 metres have been going off today from
6 metres. Very busy today, and the other day as well for us.
Yeah.
Because we're so far south.
Yep.
But yeah, it's certainly very busy today, and my antenna is still on the ground.
Right. Okay. So, just a reminder, next week, Wednesday, is a presentation night. We've got Peter Picorni coming in, VK2 EMR, via Zoom. He's actually coming in via Zoom from Sydney. History of UTC and the leap second. Now, this is a fascinating talk, but also a very humorous talk. So that should be fantastic. That's next week. We will stream that and go out on RF. And then the 1st of May, our presentation night is by yours truly, and it's on Pop Medhurst, who was A7AH. So there's a really early call sign for you. Tasmanian wireless pioneer. So if you've got your latest edition of AR magazine, there is an article in there, which is where the presentation is coming from.
Oh, okay.
So absolutely fascinating character, and definitely a man of his time. So he was a bit of an inventor, a bit of a experimenter, and has lots of things, lots of claims to fame that I'll go through in the presentation. So there you go. So thank you, Steve.
Fantastic.
That was good. I like that.
Bit of fun.
Bit of fun, and fantastic with the position indicator. That's really,
Well, I'm
really
going
good.
to try and get it in the air on Friday and
Okay.
see how I go.
Okay. Good luck. Excellent.
Yeah.
All right. We'll bid you farewell. 73, everyone. Have a great Easter. Have a safe Easter, and we'll catch you in the presentation night next Wednesday night. Cheers.
Cheers.